I want you to look at the picture that I have here of these different shapes that you see. And I want you to think about two things. I want you to tell me something that you notice about the picture, and then I want you to tell me something that you wonder about the picture. So something that you notice, and then something that you are curious about, or that you have a question about. Okay, we're going to come back to this picture again. So what I want to do is I want to talk about a circle. You've calculated area of a circle before, and you might understand that there's different parts of a circle. So let's go ahead and talk about those parts of a circle. So the first part of a circle that I want to show you is going to be the distance from the center of the circle to any point on the circle. Okay? So the distance from the center of the circle to any of those points is called the radius. That's the radius, halfway through my circle. Okay? And in formulas, you're going to see the variable, the lowercase variable r, to represent the radius. And then we have a different part of a circle, and this part of a circle is called the diameter. Now the diameter is the distance from one edge of the circle to the other edge of the circle, but it has to go through the center. Okay, so like if this is the center of my circle, the diameter is going from one edge to the other edge, but it has to go through that center point of the circle. Okay, and then you're going to see that with the lowercase letter d. So I want you to answer this question for me. What is the relationship between the radius and the diameter of a circle? So we should recognize that the radius is always going to be less than the diameter. If we're looking at the same circle, the radius of the same circle is going to have a smaller size than the diameter. And the reason is because it takes two of my radius to make a diameter. So one diameter is twice a radius on a circle. Okay, so I just wanted to go over and review these parts of a circle. And let's look at my next topic here, which is looking at the area of a circle. So if you look at your formula chart and you look at how to calculate the area of a circle, you're going to see area is pi r squared. So here's our symbol for pi. Pi is an irrational number. And then we have our radius to the second power. So that means I'm multiplying my radius by itself. So let's try to calculate the area of this circle that we're looking at right here. So the area is going to be pi times my radius squared. Now, remember that I'm not multiplying by 2. I want to square that number 6. So that's the same as multiplying 6 times 6. So I'm going to write 36 pi. And our area can be written just like this. This is called leaving our answer in terms of pi. So that means that we're not going to actually type into our calculator. A lot of people will round pi to about 3.14. This is an irrational number that continues forever and ever and ever and ever and ever, and it doesn't have a repeating pattern. So what we do to write our answer as accurately as possible is we leave it in terms of pi. So if I'm calculating the area of this circle, I could just write 36 pi as my answer. I do not have to multiply by 3.14. Okay, so we'll just leave it like that, 36 pi. But know that if you were to type that into a calculator, it would be close to, let's see. Okay, so it's very close to, 113.04. But this is a rounded number, and it's best to leave our answer as accurate as it can be without having to round it. So we're going to leave it as 36 pi. Okay, let's look at this next picture here. So what I did is I am creating this purple space right here, okay? And I want to know, what do you think is the area of this purple space? We're looking at the same circle as we saw on that last slide. And when we were calculating the area of that last circle, we got 36 pi, because it's pi times r squared. 6 times 6 is 36. What do you think would be the area of just the purple part? What if I told you that we're looking at that this was cut exactly in the middle right here? Okay, so if we're looking at what's called a semicircle, then all we have to do is cut this in half, right? Just divide by 2. So 36 divided by 2 is 18. So the area of just this part right here is going to be 18 pi. And we can write our units, square centimeters. Okay, here's another one. And I want us to just try to think, what's the area of this purple part now? Just the purple part that I shaded. What if I told you that this is called a quarter circle? That should probably help if we're thinking about what's the area of just this part of that circle. Well, if it's a quarter circle, we know that the full circle, the entire circle, is 36 pi, right? And if we have a quarter circle, that's the same as just having a fourth of it, right? So that means this right here is like a 90-degree angle, because it's a fourth of the circle. Do you remember that an entire circle, all the way around a circle, is going to be 360 degrees? All right, so what's 36 divided by 4? I'm getting 9 pi. 9 pi would be the area of just this part, this smaller purple section now that we have. square centimeters. Okay, so let's look at another picture here. Now this one might seem a little bit different to you, or maybe now it's getting a little bit more uncomfortable because now we're getting a smaller section of this circle. So I want you to think about how would we calculate the area of this spot? And what if I told you that this angle is 45 degrees? On the last slide, we had this part, right? Because it was at that 90-degree angle. So what if this were 45 degrees? Have you thought maybe here, if the full area of the circle is 36 pi, well, 45 degrees would be just an eighth of that, right? Okay, so let's talk about how we could write this answer here. So what I would suggest doing is let's simplify the numbers that we have. I know I could simplify both of these by 4, right? 8 divided by 4 is 2. 36 divided by 4 is 9. So that means we could say that the area of this purple space is 9 pi over 2. I guess technically you could, if you want, put 4.5 pi. I prefer to just leave it as a fraction. So this area would be 9 pi over 2. Okay, now I want to go back to this original picture that I had here. This was at the beginning of the video. And I'm going to give you some more context here. What if I told you that the area of our first original red circle that you see here on the left is 136 square units? And what if I told you that the radius on all 5 of these shapes is congruent, that they all have the same radius? So that means that they're all the same size, if you will, same size of circle. Like if I were to complete the circles right here, if I were to if I were to complete these circles, they're all congruent. Okay? So, if I tell you that the area of this pinkish, reddish one is 136 square units, I wonder if you can calculate the area of the other pieces. So let's say right here, let's say on the orange one, what if I tell you that this part is a 90-degree angle on the outside? Can you calculate what would be the new area of that orange part? And let's say right here that this is a half circle, so then this part right here is 180 degrees. And the green, let's say that this is a 90-degree angle. And on the blue, I don't think I'm going to be able to write that small, but let's say that this is a 45-degree angle. Okay, I want you to try to calculate the area for these. Let's call this A, B, C, D. Let's start with B. B might be the easiest one here. Okay, so how would we calculate area. I would say if I know that the full circle is 136, I would have to just divide that by 2. So that gives us 68 square units here. All right. And now what about C? We're going to go, we just solved for B. Let's then look at C, our little green part, and then D, the blue part, and then we'll finish off with A. So for C, it looks like if we have that 90-degree angle, that would be the same as a fourth of my circle. So if I divide that by 4, that's going to be 34 square units, right? Yeah, 34 square units. Okay, and then D, if that's a 45-degree angle, we could think about it as being half of the quarter circle. So there's multiple ways to solve, right? So I could take my original area and divide that by 8, right? So that's going to be, let's see, 18 square units. No, 17. Okay, so now let's come back over here to A. This one might be a little bit tricky for you. I wonder, do you know this angle? This is a large angle, right? Greater than a straight angle, greater than 180 degrees. Let's see, would that be 270? 270 degrees, right? Because if I know a full circle is 360 and I subtract 90, that's going to be 270, yeah. So that's like 3/4 of the circle, right? So I could take this and take 3/4 of it, right? So it's like multiplying by 3 in my numerator and then dividing by 4. So what would that be? That should give us 102 square units. Okay, this concept that we've just covered in this video is called calculating the area of a sector of a circle. So basically it's taking a circle, but you don't have the entire circle. You only have a certain percentage of the circle. So we just learned about area of a sector of a circle.